Hello everyone, welcome to the Math Bender. I'm Adnan Zaidi, and in this section, I'll talk about complement of a set. Now, complement means not, if I say a complement, a set complement, which means everything except that particular set. So, for example, in the whole school area, there is there's this cafeteria, there is this garden region, there's this classroom, multiple classrooms. If I say classroom complement, so which means in that school area, what other regions are there when classrooms are eliminated? So complement means that it's not a. So which means if I say a and I put an apostrophe like this symbol represents a complement. So if I say a complement, so it means not a, except a everything in that universal set. So complement, in a complement, you do understand that a universal set is already involved. So when we talk about universal set and after that, so let's say if I draw a set here, set a random, so if I say shade a complement, so a complement means everything except a. So you will shade all of this except a. This is what complement means. So let's move on and check some of the questions here first. So this is universal set, so which means all the integers. So let me write down all the sets. So 2 till 15 inclusive, which means 2 and 15 is also a part of that set. So 2, 3, 4, and so on until 15 of all the sets. A are prime numbers, so 2, 3, 5, 7, 11, 13, and that's it. Although there are prime numbers more than that, but our range is because it cannot exceed the universal set. B, multiples of 4, so 4, 8, 12, and that's it. C is going to be multiples of 2, so 2, 4, 6, 8, 10, 12, 14. Now if I say find C complement, so which means all the elements minus subtract C from it. Subtract C from it. So all the elements are here. So 2, 3, and so on till 15 minus 2, 4, 6, 8, 10, 12, 14. So you'll be left with 3, 5, 7, 9, 11, 13, and 15. This is C complement. Let's see some questions here. So I'll write down all of these elements I've taken down. This is as same as this. So when we have to draw them on a represent on a diagram, so let's write down. So this is E, or universal set, and there are 3 sets, A, B, and C. Now this is A, B, and C. Now how to fill it first? So although I've taken down all of these, let me copy that. So I have all the elements. So now first step, look for common. So if anything that is common in A, B, and C, that comes in there. So we can see that nothing is common between A, B, and C. So in B and C, there is 4 and 8 common. So I'll write 4 and 8 here. As you can see, B, 4 and 8. Now, in A and C, 2 is common. And in A and B, there's nothing common. So I'll write down rest of the elements of A in A. So 3, 5, 7, 11, 13. And for B, it's 12. For C, it's going to be 6, 10, 12, 14. Now, the remaining are, so 2 is there, 3 is there, 4, 5, which is in A, 6, 7, 8, 9 is nowhere, so I'll write 9 outside. And 15 outside as well. Now, this means none of these two elements were a part of any of those sets A, B, or C. Now, this means number of sets of B union C complement. So first, take out what is B union C. So which means all the elements in B and C inclusive. So this whole thing is B union C. And if I say what is B union C complement, so which means except B union C, all the elements, how many elements are there? So if I circle all the other elements, then I'll see 1, 2, 3, 4, 5, 6, 7. So I'll write 7 because there are 7 elements which are representing B union C complement. Complement means it's not a part of that. Now, this question, I'll discuss it in my next page. Let's see how we shade these. B union C complement. First step, highlight what is B union C complement. So which means except B union C, you write down all the elements which are all the elements except all of B and C, all of the elements. This is B union C complement. Now, shade with A. So this is A. All of it is A. Now, union, which means sum up all the elements that are in B union C complement, which was in the first figure, and A. So sum up all of them. So if I shade all of it, then I could see that whole of A is there and rest of the outer part is there too. This is common. This is all summed up. So this is A union with B union C complement. Now for this one, B union C complement again. So which is going to be, let me shade that down. all of this except B union C and A. Now, the question is asking for the intersection now between both of them. So, common between B union C complement and A. Can you see this is the only region? I'll shade it here. This is the only region that is common in both the figures. You can check. Now, if I don't want to draw these diagrams, so what we can do, we can use multiple colors here. So I'll give you an example. So here, I need to find out A intersection with B union C complement. So first step, shade all with a different color on the same diagram where there is no B union C. And then shade A with a different ink. Now, intersection means overlapping. Can you see that this is the region that is being overlapped? This much only. So hence, you can do that thing in one page as well. So let's look at another question here. Now, P belongs to A intersection B. So for first one, I'll have to write down all of these P, Q, R where they represent. So P belongs to A intersection B, and this is where P is going to be. Q belongs to A union B complement. So except A and B all summed up. So A union B complement is Q. So somewhere here, because this whole thing is A union B, and it says that it belongs to the complement. So the complement, so I'll erase where Q. And the last one is B complement intersection with A. So first step, what is B complement? So if I shade that, except B, all of the region is B complement, except B. And intersection with A, so shade A as well. All of the region is A. Now, which element is common? So can you see that the overlapping is in this region, which is R only, not here. This was not overlapping. So now, if I have to write that down, this is R, this is P, and this somewhere here is Q. Let's look at that question again. So number of elements of A union B intersection with C complement. So first step, let's shade C complement. So if I shade C complement, then everything except C. So everything except C. And then A union B. Now shade A union B as well. This whole thing is A union B with green ink. And now there's an intersection common between both of them. So common between both of them is the region that you can see. Just count these elements. So 1, 2, 3, 4, 5, and 6. 6 elements, because you just have to find out the number of elements. So this is all about complements and their Venn diagram representation. In my next session, I'll talk about word problems related to sets and Venn diagrams. That will be the last session. Please write in your comments if there is any suggestion or any question that you would want me to solve. Until then, take care. Bye bye.